Okay, students, now comes the part 2 of your final exam, and that is about the Laplace, to find Laplace transform of this function, and based on that you are asked to find this integral. So how is this done? So simple. What you need to do is you need to recall the definition for, a Laplace transformation and also properties of Laplace transformation. So if you remember, students, in our class we have studied how you can transform Laplace of a certain function divided by t. So the Laplace of a certain function divided by t, as you see, this is a numerator function. Divided by t is nothing but it is the integral from s to infinity of the Laplace of this function ds, right? So we have to find the Laplace of this numerator expression, which actually is 1 over s plus 6 for this particular case, minus 1 over s plus 2 for this one. So as I said, this is the integral from s to infinity of, you see, the Laplace of this is 1 over s plus 6 and minus the Laplace of this one is 1 over s plus 2. This was the property we were having, right, in the Laplace transformation. Now from this you need to recall how you can find the improper integral of this one. So this is going to be the same as this. As you see, b is going to infinity, so here infinity is held by b, as you see. So the limit from s to b as b going to infinity of 1 over s plus 6 minus 1 over s plus 2 ds can come. Now, dear students, we need to find the integral of this one first, and then b and s are going to be evaluated one after the other, provided that this is taken into account. So from this, the following can follow. The limit as b going to infinity of, now dear student, that this is ln s plus 6, and this is ln s plus 2. So we can unite the two by using over. Remember logarithm property. So as you are putting b in place of s, ln of b plus 6 over b plus 2 can come. Then minus comes because of the fundamental property of fundamental theorem of calculus. Then you need to put s in s there, then you do have a minus ln of s plus 6 over s plus 2. So the limit is analyzed on b, so this is nothing for, you see, this limit, because this is treated as a constant one, we don't have b there. So as b goes to infinity, this is going to be ln 1, right? Because take ln out and analyze the limit as b going to infinity of b plus 6 over b plus 2. Okay? Because as b goes to infinity, b plus 6 over b plus 2, both are, you see, positive expressions, no problem. So the exponent they are having for the numerator as well as for the denominator, you see here is 1, number 1. So we can take leading coefficient ratio. Just we are having 1 here, again 1. So 1 divided by 1 is 1. So the limit ln 1 can come. And we know that ln 1 is 0. And we know that ln 1 is 0. 0 minus ln of s plus 6 over s plus 2 can come. And from this, what comes next is this expression, negative ln of s plus 6 over s plus 2 can come. So this is negative, so I can take this as ln of s plus 2 over s plus 6, because I can take the reciprocal of this one, because negative 1 can be taken up. So this is finally ln of s plus 2 over s plus 6. So dear students, what comes now is, you see, the Laplace of this function f of t is the one we are having here, is obtained to be ln of s plus 2 over s plus 6. But the other question that we need to answer is this one. What about the integral from 0 to infinity of e to the power of minus 2t f of t dt? So dear students, if you remember, this is Laplace definition at s2, right? At s2. We already have defined what Laplace of f of t in terms of s. So in order to obtain this one, you see, just a matter of using 2 in place of s, because this is the Laplace of the function f of t at what? At s2. So you simply put 2 here, and then the following can be what? Obtained. Look, the Laplace of f of t is directly this one, because the function we were having at f of t is this. And by definition, the Laplace of this function is s, is a power of minus st times f of t dt, as you see. But here in our question, we're having is a power of minus 2t times f of t dt. But this is already determined as a ln of s plus 2 over s plus 6, because the Laplace of this is already obtained from the previous slide. So when you take s to be 2, you are going to have this to be like this. When s is 2 students, this is going to be ln of 1 over 2. Basically, dear student, there is one thing that I would like to add here. Here we are having e the power of minus 2t, okay? Look, in place of s, 2 has to be used. So the integral from 0 to infinity of e the power of minus 2t must be added here, students. It is forgotten, please try to add that here, okay? e the power of minus 2t times e the power of minus 6t minus e the power of minus 2t over t is going to be ln 1 over 2. But we knew that ln 1 over 2 is the same as negative ln what 2. So the Laplace is helpful in order to find integral of this kind. Now what comes next from this is the following one, okay? You are asked to evaluate this integration. As you see, you are asked to evaluate this integration. So this is basically line integral of a scalar function, because of scalar function is xy minus z, and c is the line segment from minus 1, 1, 0 to minus 2, 3, 0, 2. So initial point as well as terminal point is given. So what we need to do to find this integration is we have to know the parametric equation of this line segment, and based on that we can determine, you see, the line integral of this scalar function. So the solution goes like this. The parametric equation of this line is obtained to be this one. What I did here is I took the initial point as it is, minus 1, 1, 0, plus t times, this is a parameter t. Now deduct this one from this, minus 2 minus minus 1, which actually is 3. Minus 2 minus minus 1, which actually is minus 1, right? Minus 1. And 3 minus 1, which actually is 2. And 2 minus 0 is 2. So the initial point minus 1, 1, 0 plus t times minus 1, 2, 2 can be taken. Our t range is from 0 to 1, because when t is 0, the initial point can come. As you see, when t is 0, this goes 0, the initial point can come. And when t is 1, okay, the terminal point, this one can come. So whatever point you may take now between 0 and 1, a point on the line segment can be obtained. So this is a parametric equation, okay? So your r of t now comes to be, look, this one. What I did here is minus 1 plus minus t, it is minus 1 minus t, and 1 plus 2 times t, 1 plus 2t, as you see, 0 plus 2t, it is what? 2t. Once you have this, you need to derive this one, because here in x, y and z expression here, we are going to use this expression of t's, and we know that ds is the norm of the derivative of what? This parametric equation times dt. So we have to find the derivative of this one. What is the derivative of x? It will be minus dt with respect to t. It's minus dt with respect to t, it will be 2 dt, and this one again comes to be 2 dt. So from this, the integral of xy minus z ds is going to be the integral from 0 to 1 of f of r of t. When I say f of r of t, I mean in place of x, y, z here, we're going to consider x of t, y of t, and z of t, and we need to take the norm of the derivative of this parametric vector r of t dt. And then this is 0 to 1 of, we know that this is x times y, so x times y will be minus 1 minus t times 1 plus 2t, as you see, minus, it says z, so z here is 2t, it's directly taken. Then we have to take the norm of, you see, the norm of the derivative of this one. The derivative of this is minus I, and the derivative of this one is 2j, and the derivative of this one is 2k dt. This is how a scalar function, the line integral of a scalar function is defined. So dear students, know that this is equivalent of this one. You see, in our class, if you remember, we defined the line integral of a scalar function as like this, and based on that, we simply took the parametric equation of the line and substituted as you see. So the next task is a matter of now evaluating this one. So from this, the norm of this minus I plus 2j plus 2k makes 3, because the square root of 1 plus 4 plus 4 makes radical 9, and that is 3. So integral from 0 to 1 of minus 1 minus t times 1 plus 2t minus 2t can come, and after simplifying this you will obtain that to be this expression, minus 1 minus 5t minus 2t squared. So integration of this is going to be done one after the other. So you will get this to be minus t minus 5t squared over 2 minus 2t cubed over 3. Then we need to put t 1 in place of t. So as you are substituting 1 in place of t, you will obtain this value. And the final output of this now comes to be negative 25 over 2. Thus, when you evaluate this like this, you see, you will obtain the value or the final output to be negative 25 over 2.